In this episode of Cube FM, I got a chance to speak to Hans, who's a seasoned site reliability engineer. Hans shared his journey with me about OTel and Prometheus, discussing how these tools have shaped his approach to cluster management as well as observability. We explore the concept of shifting down in platform engineering, highlighting how Kubernetes facilitates self-service infrastructure through a declarative API and through fault tolerance. Han sheds light on essential tools like Argo CD and Flux, which enable GitOps and streamline deployment processes. He emphasizes the importance of governance with tools like Gatekeeper and OPA to ensure secure and validated resource creation. We also got a chance to touch on the power of custom resource definitions, CRDs, and operators in automating processes and enhancing developer experience. Finally, Hans offers insights into emerging tools such as eBPF-based observability and Victoria metrics. Check out this episode for a comprehensive look at simplifying Kubernetes complexities and achieving scalable, reliable software delivery. We know that Kubernetes has become the cloud's de facto operating system, transforming application packaging with microservices. Yet at the same time, complexities often delay crucial security measures until production. With 70% of containers lasting 5 minutes or less, rapid detection of anomalies is vital. Time is critical for DevOps teams. Get Sysdig's 5 steps to securing Kubernetes checklist and learn how to become ready to tackle challenges at cloud speed. Now, let's take a look at the episode. All right, Hans, welcome to the Cube FM podcast. I want to start out by asking you, what are 3 emerging Kubernetes tools that you're keeping an eye on?
Yeah, that's a great question. Thanks for having me. And I focus a lot on observability and how we build applications for Kubernetes. So the 3 that I'm kind of focused on are eBPF-based tooling, like Ground Cover, Retina, things for observability that kind of help us really get instrumentation without needing to do much on our side or on the application side. And then things like KApp or CAP and related tooling around abstracting applications themselves, right? And building a better language for that. And then, even though this one isn't terribly new, it's been out for a while, but it's slowly kind of building, is tooling around Victoria metrics and kind of Prometheus alternatives and how we think about metric collection in general and cardinality and things like that.
Okay. With that in mind, one of our guests talked about how she preferred OTel over Prometheus. What's your experience been there?
Yeah, so I think I agree. I really like OTel. I like that it is not just metrics. Like Prometheus does metrics really well, but it also is kind of a single box and sharding and all of that gets really complex. And OTel kind of makes that a data pipeline. And Kelsey Hightower, I once listened to him talk about specifically kind of managing Kubernetes, managing telemetry data, and he said once you start thinking about your stuff as a data pipeline it will start making a lot more sense because then you're just moving data from here, you're transforming it, and you're putting it over here. And so all of a sudden, using OTel to do that, it makes it far easier, far simpler, and you can have the same pipeline for all of your telemetry data.
So, in terms of context, can you just tell us a little bit about what you do? We know about the tools that you're interested in, but how do you apply them? What's the kind of stuff you're working on?
Yeah, sure. So I'm generally kind of a staff level SRE, staff plus level SRE, helping build Kubernetes platforms for teams. Um, Big, small companies, I spend most of my day working on kind of improving how we manage Kubernetes clusters, right? I think that's a new and emerging area is like instead of just one cluster, we manage 50 or 100 as kind of needed. Um, and then focus on how do we observe what our Kubernetes clusters are doing, what our services are doing on the clusters, working on production engineering, so thinking about how we release to our services safely and quickly, and then figuring out what level of abstractions for our developers. And I've done that for large and small companies, from everything from banks to satellite companies, healthcare, credit cards, and then a bunch of kind of smaller niche startups.
All right. So you've really touched a lot of different areas in that regard. And what about your experience getting into cloud native? Tell me about that.
Oh yeah. Well, I discovered that I was a uniquely, or I was by nature a lazy person. So I started off as a kind of help desk, tier 3 help desk for big ISPs and telcos doing business stuff. and I moved into a small, kind of a small software company as a sysadmin, managing their data center. And they had a colo, and so we racked and stacked servers. I managed all their networking. I built their servers, handled the imaging, and all of this. And this was back in like 2014. So cloud had started to take off, but they were the furthest thing, right? We were still using Pixie Boot to manage all of our stuff. We were doing things like that, and I discovered that I was by nature a lazy person, and so instead I didn't want to have to do things more than once, and so I learned to program because I didn't want to do things more than once, and the way to do that is solve that in kind of the computer world, right, is to learn how to program, learn how to script, and take something that was me sitting there clicking through a UI to install software, install an operating system to, cool, how do we do a Pixie boot across the network? How do we start setting up SCSI drives without having to manage the host directly? Things like that. Um, Having spent a year or two kind of building out this private cloud in the colo, I then, it was pretty easy to step into the cloud world and have a much better understanding of like how what are the challenges, what are the benefits, what are the pitfalls of moving to the cloud, because I had built this other one for this company on Proxmox, on kind of our own private little thing, and that gave me a ton of great insight. And so then I kind of stepped over and used all those programming skills to never have to touch a server again. So
It's the first time we've heard someone approaching this from the idea of being lazy, but I really like how you frame that. How do you work yourself out of a job? But in terms of the Kubernetes ecosystem, now that working on Kubernetes platforms, how do you stay up to date with all the changes that are going on constantly? What works best for you?
yeah, no, I mean, man, sometimes I think we give the front end JavaScript world a run for their money on how many updates we ship and how many new tools. Um, but I tend to read a lot, so I'm and listen to podcasts. So I tend to be able to read while I'm doing other things, and so I have a couple. There's there's platform engineering that does a weekly one. There's a DevOps weekly that both kind of help out. Um, there's a Substack or a thing that goes out from Grigorly Ozov about kind of excellent engineering and what that looks like that helps me keep track. But then also just like spend time, listening to the talks from reInvent or from KubeCon and things like that. But like the honest answer is no one can keep up with all of it. So like, yeah. Yeah.
I agree. And so, but still finding those, go-to resource and what works best for you. And I really like the JavaScript thing. That's something that hadn't been mentioned before. And I think is a worthy example that's worth keeping in mind. If you could go back in time and give, one piece of advice to your or career tip to your younger self, what would it be?
I think taking more risks. So I think that when you're a junior engineer and you're just starting off, it can be hard to feel empowered to kind of take risks on what you're proposing, what you're solving, how you're doing it. And so, if I could go back and talk to myself in 2014 or 2011, it would be, take some more risks, not necessarily in who you work for, but in like the projects that you take on or how you approach those projects. Don't get stuck in, oh, you have to do it this way because someone, in the company said that you had to do it this way, or because we've always done it this way, right? Go, take the time to kind of see how you can step out, how you can improve what we're already doing, with some modicum of caution there, obviously. But like in general, I think that junior engineers, and myself included, we tend to focus, or they tended to focus on like, okay, how do I get this done within like the narrow context given to me, versus how do I go solve this problem in like the best way, in a way that will scale and perhaps in a new and like inventive way that we can apply to other resources as well, or other areas of focus.
Now, as part of our monthly content discovery, we found an article that you wrote titled "Platform Engineering: Learning from the Kubernetes API." So we want to dive into that a little bit deeper. You've been working in cloud and infrastructure for over 10 years. You mentioned, going back to 2014, but just walk us through again. How have things changed since you started?
When I first started, this back in like 2011, and started doing stuff even before I actually got to like put hands on keyboard in the corporate world, right? We were beginning to see kind of cloud take off, and we saw none of the tools that we had today, right? Kubernetes in 2011 would not be released for another year or so, or like officially come out. We would like none of the AWS tools, right? AWS offered like EC2, S3, and RDS as like primary things. All the rest of it was like barely starting to kind of flesh out, and all of the tools that we saw come next were about how do we properly abstract things that we're doing on EC2? How do we abstract things that we're doing in RDS, in S3? And for a long time, we had a bunch of conversations about shifting left. There's a whole DevOps revolution here of like, okay, how do we shift things left in the CI pipeline, or the CI/CD pipeline, so that we move it closer to the beginning, so that we learn about problems earlier in the process. We empower developers to make changes. And that went really well. It obviously abstracted a ton of things, and we've gotten a lot more productive. But I think towards the end of like the 2010s and into the beginning of obviously this decade, we've seen that doesn't work all the time. And it adds a ton of complexity for developers to interact with all of these things. And so Google's Richard Sarator put out an article mid last year that was called, Shifting Left is for Suckers, Shift Down Instead, and talked about kind of a new paradigm to this. And I really latched onto that because it described kind of a similar challenge that I had run into multiple times over the last decade, which is developers don't need more complexity. Developers care about taking their code from their laptop to production as quickly and safely as possible. They don't want to manage ports on a Kubernetes service. They don't want to manage, how big their RDS instance is or how much memory they need to assign. They don't like want to manage those things. If they don't have to, right? There are times where you have to, but if they don't have to, they don't want to. And so shifting down versus shifting left basically acknowledges that, and describes a model where instead of taking all of the customization options that are possible in the cloud, which are infinite and vast, and just moving them left in the process, it says, okay, how do we give you a abstract, opinionated version of this that allows you to kind of quickly iterate, and you should still be able to tweak knobs and turn things when you need to, modify when you need to, but in the 99th percentile, or 95% of the time, you don't need to. You can just ship an app, and we've seen this take other forms. Other people sometimes call this a golden path or a paved path approach, where you have a platform team that says this is how you do things most of the time. But being able to kind of abstract what you're doing and increase your layer, so that people don't have to think about it, is kind of the principle here of shifting down. And I think that's the primary, the primary change was, okay, how do we go from everyone gets everything but late in the process to now we get everything early in the process? And that was shift left, how we find these problems early. And now we're moving to the, okay, how do we abstract this so that you don't have to think about it if you don't want to, process?
The industry is moving, as a general trend, more and more towards self-serve. We see that as a way for companies to create less dependencies between teams. Even roles such as, SREs blend the skills of developers and operations even more. How does shifting down help with self-service?
Yeah, I mean, like, okay, the thing is, every developer at virtually every company I've ever talked to has been like, why can't our cloud just be like Heroku? Why can't we just use Heroku? Like, all I want to do is put my code in a thing and have it served and scale. Um, and Heroku doesn't scale kind of the way you necessarily need it to in an enterprise environment, but there's something there that like they're telling us that says, hey, we want to be able to have the smallest amount of scaffolding and extra stuff to be able to ship our code. And this is one of the reasons why I think Kubernetes has been really successful, is the Kubernetes API allows you to say, or provide a common interface. And it says, even inside Kubernetes, we've built these abstractions. We take a pod into a replica set or a stateful set, and then a replica set into a deployment, and then a deployment, into something higher that you're abstracting as a platform team. And so being able to kind of blend, like from an SRE perspective, for example, right? We're blending developers and operations where we have an understanding of what developers want to achieve, what their developer experience concerns are, and how do we implement those, in the Kubernetes API or in any API in like an effective way. How do we deliver a Heroku type model for engineers so that they can ship quickly, safely, and efficiently? Because no engineer wants to get stuck in a security review process or an architecture discussion about how many pods or what metrics should we scale off of, or things like that. And so this is, again, like I talked about in the article, where the Kubernetes API really really shines. It lets you take all of these abstractions that we have, a service and a deployment, and all of these custom operator resources and all of that. And then you can write your own operator, or you can use, something like Crossplane to abstract and build out, or you can use something like, CAP or KAP to build these out and say, hey, I I want to deploy a version of this microservice, and then something else does the interpolation and the logic behind how do we actually ship that, and reconciles it so that it's always there, so that it doesn't disappear on you just because you deleted a pod, and makes kind of intelligent decisions and has correct defaults and all of that, and so um, yeah, I don't know. It shifting down should help you let developers make informed choices, but make informed choices quickly. And I think that is, yeah, kind of the primary goal there.
Considering that Kubernetes isn't exactly the easiest platform to learn and something that a lot of developers would probably rather just avoid entirely, how can Kubernetes help with self-service then? What's the role of Kubernetes here?
Kubernetes is it's actually both really really simple. Like, hey, I just want to run this container, and if you're just using it, you just say, hey, give me this pod, and it just runs and works. But also from an administration standpoint, or from a how do I define that container? How do I make all these choices? Right? It becomes, like you mentioned, kind of really really complex really quickly, and so there are a couple of things that become really important. So when we think about the Kubernetes API, the first thing we think about is that it's declarative. I as a developer don't have to say first do this, then do that. I can simply say, here's my deployment, run it. And Kubernetes will kind of take care of that. And if I, you know, want to change something in my deployment spec, I can go change that. And the same is true for other custom resources that we're interacting with in Kubernetes and that we're managing, right? It's a very declarative system, um, which helps remove some of the complexity. I can't even imagine how complex Kubernetes would be if you had to do imperative kind of design and scripting of the various parts. Um, the second is idempotency, right? You can submit the same request over and over and not have a problem. This enables things like GitOps that allow us to use a tool like Argo CD to kind of abstract some of that complexity and be able to ship it all on a regular basis and say, hey, I want to put this manifest in here, and it can sync it over and over. It can validate that it's still going, and every time you do it, you're not worried about breaking your service. I've written plenty of Ansible and Puppet and Chef and other, even Terraform, other configuration languages or infrastructure as code languages, and they all run into a very similar problem of, at some point someone is going to write a little loop that is going to break because it's not actually idempotent. It depends on something else being there. It depends on a request in a particular order. Um, Things like that. You don't have to worry about that with Kubernetes. You say, I want these three things. If two of them already exist, it only creates the last one, and everything kind of works and handles that. And the third one is fault tolerance, right? Kubernetes is not just a Docker Compose stack running on an EC2 instance. It allows you to scale past multiple machines and, from a developer experience, really treat all of the compute, all of the memory, all of the storage in your Kubernetes cluster as fungible. And so you don't have to worry about, can this VPC talk to this VPC per se, right? If the Kubernetes cluster spans it and has the routing set up, then all you have to worry about is let me call, this endpoint. Let me talk to this service and cover how I go from service A to service B and how I deploy those out and how I manage them. And then Kubernetes isn't the only tool here, right? You could try to build. It has certainly benefits, but there are other container orchestrators that do similar things. But I think the big benefit then that the Kubernetes gives you is, hey, I can extend this. I can write my own custom operator that does the idempotent thing or the declarative thing and builds that out so that a developer doesn't have to think about it, right? You can write a Helm chart, which is a nice little API basically for how to deploy a particular service. There's all these very very useful tools that can be built on top of it because of kind of these three core principles of the Kubernetes API.
Regarding, you did mention talking about infrastructure as code. You did mention Terraform. Some of these properties, such as idempotency, are found in other tools, and Terraform being one of them. Does it make a tool like that? Does it make it, also a tool for self-service?
Yeah, so kind of. I think the big I have written Terraform now for just under a decade. I've written a lot of Terraform. I've written a lot of configuration as code, and the problem that comes into play with Terraform or any configuration language is the lack of reconciliation and the ability for stuff to drift. And there are tools that help you solve this, Atlantis or Spacelift or Terraform Cloud, or even if you use Crossplane or a Terraform operator inside Kubernetes. But basically, the fundamental problem remains that with Terraform, you need something external to the Terraform itself running the Terraform on a regular basis. And there is no standard for that. There is no standard API. There's no standard runtime. There's not that. And so it's very easy for you to write the best Terraform in the world, you go deploy it, and then someone goes and clicks a button in the UI and breaks all of it. And without intending to, because there's no reconciliation, there's no ability, to easily write tooling that says, hey, you shouldn't do this or you can't do that. And that's, you know, for Kubernetes, that again, another area where it shines is I can write tooling that I know will parse the spec of the Kubernetes API resources, right? All of those CRDs are open API spec resources. I can write CI tooling that says, hey, you probably shouldn't be doing this, or we're not going to let you do this. I can write things, in Kyverno or Gatekeeper that act as a admission webhook that say, nope, you're not allowed to do this, or yes, you're allowed to do this, but we're going to modify this, right? The concept of webhooks, of admission, validating, and mutating webhooks in Kubernetes allows you to say, hey, I'm gonna take what someone meant to do, and I'm gonna improve that semantically and meaningfully improve that, and you can't do that with Terraform very easily. There's no way to abstract on top of it. There's no way to hook in like a pre-hook somewhere, um, something like that. And so that, you know, yeah, that's kind of where Terraform falls apart, and that you need the state file. That the state file is contained separately, and so you have to start referring to other objects and those permissions in S3 buckets, right? Again, Terraform is just a language. It's not a runtime. It's not an API server. It's none of those things. And Kubernetes kind of really shines when you hook all of that together.
Hmm. And you can also have state drift in Kubernetes if you use kubectl and don't store your YAML file in Git, right?
Absolutely. I once joined a company as they were using Kubernetes, and I was like, "How do you deploy your software?" And they go, "Oh, we just log in via the command line and run Helm update or a kubectl update." And that was including in prod. And so if someone remembered to go do that, that was basically how they handled that. And that's absolutely true. But there's two big differences, and I think the important part is to recognize where drift is happening. So there's drift from what you have declared in your code and submitted to a, and then there's, or what's in your Git repo. And then there's drift from what you have submitted to like a reconciliation API server or something like that. And Kubernetes really solves the second one really conveniently, right? If you tell it, hey, I want a deployment with 3 pods, it will do its best to put 3 pods out there and run those 3 pods. And then, to your point, you still could have drift. I could go into the Kubernetes server and delete that deployment, and then that deployment won't exist anymore, and Kubernetes will be like, cool, I don't need that deployment anymore. So then we invented this concept of GitOps, and we were like, hey, well, you know, we are no longer just uploading files for our services as we write our web application, our application code. We're no longer just uploading that to S3 and hoping people can hit it and then deleting the files. We're no longer just SFTPing it into a server and just copying them over and being like, cool, we updated our stuff. And that's kind of the equivalent, right? Like the equivalent to using just kubectl is just like a SFTP into a server and copy some files from your local machine. And we said, hey, we're using a VCS or a version system for our application code. We should use that for our infrastructure code. And if we're using it for our infrastructure code, we should just have something that says, oh, and it just listens and says, I need these objects in my cluster. I need them, whatever. Here's my desired state, which gives you all the benefits of PR. And so a couple of really good tools for that for Kubernetes. Argo CD and Flux are kind of two big ones, but there are other ones. They have their strengths and benefits for each of them. But I think the big driver for both of them is you remove this drift, right? You run a single set of pods or a small set of pods inside your cluster, and all of a sudden everything you do for all of your infrastructure can happen via APR, via the regular approval process, and it can extend past your Kubernetes cluster. Like that's one of the big benefits is there are tools like Crossplane or Config Connector for Google that allow you to manage your cloud resources from your Kubernetes cluster, and so that you can then start writing a consistent developer experience for, hey, I need to create a database, and instead of having to write a developer experience, a security pipeline, all of that for both Terraform and for your Kubernetes resource, you can do it for one because they can just declare their need for a database as an RDS instance or a Cloud SQL instance as a Kubernetes resource. And then you can apply the correct transformations, the correct security rules to that, and then it goes and creates it. And so all of a sudden, not only are you managing in cluster resources, you're managing out of cluster resources. The developer experience is better, and you're doing it from a very controlled and compliant manner. GitOps is amazing for when you want to try to go be compliant with various frameworks, right? Because you can say, yeah, no, nobody can make a change outside of this PR being properly reviewed. When it is reviewed and merged, then that change goes and happens. You can scope all of the resources and permissions, and no one needs, write access to a UI. So
You mentioned, developer experience, but focusing on that point for a second, if we already have Kubernetes and then we're adding additional tools like Argo CD or Flux to facilitate syncing resources, it can become quite a slippery slope from here. And then we'll have, Prometheus, Istio, Hotel, all the other tools we've been speaking about already. You name it. Isn't this the reason why some developers are drowning in complexity to begin with? Do you feel like we might be setting developers up for some kind of self-sabotage with the amount of tooling that goes into it?
yeah, this is a great question. And it really gets to the heart of the difficulty of running software at the scale that we do today. Um, you know, 20 years ago, no one cared whether your software was down for a few minutes in a day. Like they would just refresh their browser. But now, if your software is down for a few minutes, that could mean that somebody's emergency call doesn't go through, or somebody's healthcare data doesn't get uploaded, or that someone can't communicate other, again, critical life saving kind of information. Or it could cost you, half a million, $100 million, however, it depends on how big your company is. And so there's there's a kind of inherent complexity, and then there's added complexity. And so if we say, I want my my application to run at this amount of uptime, then there are just there's inherent complexity in being able to do that. You have to be able to monitor your stuff. You have to be able to release safely. You have to be able to handle an availability zone going down or being unavailable. Those are inherent to your desire to run software at a certain availability. And because the honest, you have if you want to monitor your software, if you want to know when it goes down, you need some kind of monitoring software. You could run something like Zabbix or you could run Prometheus, but something has to be running to monitor that software. If you want to handle an availability zone going down, you have to have something that handles the shifting of a pod from AZ1 to AZ2. Like something has to be able to handle that. If you want to handle certificate renewals, something has to do that. And so there's this inherent complexity in the level, I'll say the leveling up of our software writing skills and the demands that we have on delivering software at a reliable, scalable method. Like those demands have inherent complexity. And so I have found that Kubernetes is the best way to abstract those, to say, okay, I can write a Helm chart. At a former company, we wrote a Helm chart that every service, 250, 300 microservices, all used. Why? Because it gave them a single values file to interact with, and they could turn on. They got a service monitor by default. They got Canary releases by default using a tool called Flagger. They got you know, a Cloud SQL database set up correctly with proxy, with a Cloud SQL proxy and the correct service accounts and the correct IAM permissions. Like all of this was wrapped up in a single Helm chart that someone could interact with. And if you start separating those pieces of tooling into different platforms besides Kubernetes, you can do that, but you have to have something that interacts with all of those to provide that consistent developer experience. And that, in my opinion, is way more complex. And then you have like yeah, and there's always a question of when you should introduce those pieces of technology, right? Like, hey, I need MTLS. Okay, maybe I don't go straight to Istio. Istio is a big, complex thing to manage. It has amazing features. I love Istio, but it is very complex, especially to administer and run. And so maybe I step to something like Linkerd that is expressly for MTLS and is a little easier to set up, requires less complexity for the developers. And then at a later point, we move to that. Same thing with monitoring. Maybe I start with Prometheus. Why? Because Prometheus comes installed in my cluster, my EKS cluster as an add-on. And then we move to something like OpenTelemetry. Or maybe I start off, like the company I mentioned, we start off with kubectl apply and Helm apply, and then we move to GitOps once you have more than one or two people interacting with your cluster, right? Like there's always a give and take to when you introduce that complexity. But, in my experience, it's less the ecosystem that you're in that adds complexity and more the underlying problem you're trying to solve of, hey, I want to deliver reliable, scalable software automatically. How do I do that? Well, then you need a lot of these tools. Uh,
I think that's good. Is not so much freaking out about the problem, just getting the right framing on the solution. That's a refreshing take. Are there other aspects of Kubernetes that you think that work well with self serve?
yeah, like I mentioned earlier, the ability to abstract really human manual processes. So for a long time, for a former company that I worked for, Capital One, and then for a company, Mission Lane, that I worked for, we ran Elasticsearch for logging or for search capabilities and for a variety of other things. At Capital One, when I was there, the team we were on, we ran Elasticsearch on EC2 instances provisioned by Terraform that used a variety of scripts and auto scaling groups to kind of scale up and scale down and manage how this cluster worked. And at Mission Lane, we ran a Elasticsearch cluster that was much bigger, but that was handled automatically because the Elastic operator exists. And Elastic had gone out and written a tool that let you just say, I want an Elasticsearch cluster. handle the deprovisioning of a node, handle the movement of data, handle the segregation of data, handle the sharding of data, handle the RBAC for me, handle the certificate provisioning for me, handle all of that. You can just say, I want this cluster. And it goes and does that. And that again, that's where Kubernetes shines. The ability to take what otherwise is a bunch of manual processes, a bunch of imperative stuff and scripts written into Terraform or Ansible or whatever you've written, and say, I can genericize this, I can put it in an operator, and I can then say, I would like an Elasticsearch cluster. Another good example is a Victoria Metrics operator or the Prometheus operator. You can go to one of those and say, I want a Prometheus instance, or I want a Victoria Metrics cluster. And it will give you the Victoria Metrics cluster. It will give you the Prometheus instance with all the correct things kind of provisioned, and takes care of all of the previous, manual steps, which is where the term operator comes from, right? It's replacing a human operator with doing things. And I think that really shines. Like, those are very good examples of how do you take something that is really complex to operationalize if you're not aware of it, and instead make it to a kind of a single, give me an easy way to interact with this and scale and manage that resource, because the people who write the Elastic operator have a far better understanding normally of, like, when should I call this API endpoint to deregister a node, etc. You get the idea.
And, mentioning resources, someone once said that CRDs, custom resource definitions, are one of the best features of Kubernetes. What's your opinion? Do you agree, disagree? Any other feature you like more?
No, I mean, I think this is by far my favorite feature, and this is, I think, the feature that separates it from something like Nomad or something else, is the ability to write these custom resources, to have an API and an operator that says, "Hey, I here's a spec. I want to be notified when this thing happens, and I will provide back consistent messaging and all of that." And because this is a big differentiator. This is what allows you to abstract. It allows you to move faster than the Kubernetes core team, who by themselves move very quickly, right? And we have a 6-month release cadence for Kubernetes, but or 3 months, whatever, quarterly or biannually. I don't know. Anyone who keeps up with that is doing better than we are. But CRDs allow you to move faster and be able to say, I want to do this other thing that isn't intended. I want to be able to do this new and unique. Provide this abstraction to my developers, to other engineers, or to other users on a way that we can't outside of that, right? Think, if you're not using Kubernetes for this, you have to, stand up some lambdas, you have to, and you have to have your own UI. You have to build a CLI to interact with your stuff. There's all kinds of different things. AWS doesn't allow you, for example, to, like, really easily build abstractions on top of their infrastructure. You have to stand up your own EC2 instances to listen, provide a host name for people to call in. You have to write your own CLI, write all of that. Kubernetes gives all of that for you. You just say, here's my CRD. People can now interact in a common language. They can, you can get webhook validation, all that. Anyway, yeah, no, CRDs are my favorite. And you can, I mentioned in the article using cross-plane or config connector. These are some of my favorite examples of this, right? The is mind-blowing, to especially to someone who's been around for a while now, that we can, in a Kubernetes cluster, say, give me a Cloud SQL database, and have that Cloud SQL database just pop up in Google Cloud properly, or again, an Elasticsearch cluster, or a S3 bucket, or all of those things, which means I can abstract all of my app concerns, put all of that infrastructure together, and I don't have to worry about writing Terraform for one thing, Python for another, Ansible for another, right? I can just write Kubernetes. I can ship containers that are going to work, and know that my CRD and my operator will take care of it. Obviously, from the management of the cluster side, CRDs and operators take more work because we have to manage them as a platform. But from a developer experience, I think there's very little that is kind of at that level.
From what I gather, being able to self-serve, create CRDs and things of this nature come with great power. I assume that teams that are also doing this must bear some significant responsibilities.
Yeah, it's as a sysadmin, it's always a little scary to give developers the ability to create IAM roles or create S3 buckets or RDS instances or potentially even more complex pieces of software on a self-service basis. But fundamentally, they are also engineers. They have slightly less context than us sometimes about all of the considerations that go into it. They have slightly different incentives, but they're also engineers. We trust them. They're delivering the product, and so the the way to do it in Kubernetes is governance, right? And to use a tool like Gatekeeper and OPA or Kyverno to limit and restrict what things you don't want them to do, and provide. And if you do that, you can provide a consistent tooling for all of the cloud resources. A common one that AWS now has fixed, but for a long time, right? If you created an S3 bucket, it would be public, and so if you don't have a CRD or a Kubernetes pipeline or a data pipeline in general for creating those S3 buckets, there's a lot of tooling that was built around this, to manage that, to make sure developers don't click the wrong settings, exposing S3 bucket with all of the company's information, things like that. OPA Kyverno solve that inside the Kubernetes world. They say, hey, just write a policy that blocks that and says you're not allowed to create the object with that. And then Capital One, as an example, right? They wrote Cloud Custodian. That's this massive project that runs in Lambdas, whose sole purpose it is to catch these misconfigurations. This is before AWS released AWS Config and some of these other tools. AWS came out and released a bunch of tooling around this, right? And a lot of those, not the need for them because you may still want to run them for compliance purposes, but from a developer experience point of view, those go away when you can just have a Kyverno webhook that says yes or no to your S3 bucket as you submit it, and even that you can run Kyverno policies against or outside your Kubernetes cluster. So you can run it as part of your CI pipeline. When they make a PR and they say, hey, I want to add this S3 bucket as part of that CI pipeline, you can say you're going to be allowed to or you're not going to be allowed to, create this resource. And that is really powerful to be able to surface those policy violations and requirements in a consistent manner inside the cluster and outside the cluster to developers.
The things that you're describing, they sound very promising. How can you tell us about, how you've seen it in real life, and have you seen it in real life?
I have, yeah, yeah. So I was lucky enough to work for Mission Lane with a group of very, very talented platform engineers and engineers overall. But like I mentioned earlier, we had 250 some odd microservices, between 200 and 250 microservices, all using a Helm chart that we had written that you know and all of their cloud resources for their applications and services were deployed via Kubernetes objects. So we had Kyverno pipelines and admission controllers and policies that said yes or no to particular resources, that checked for particular fields, that validated what we were doing correctly. We had we had subcharts to handle. Hey, I want a Cloud SQL instance. Hey, I want a GCS bucket. I want all of that. And then we had a template that said, hey, I as a developer, I want to just I clone this template repo and I get a default installation of my Helm chart. I get all the default code that I might need to stand up this microservice to ship it in CI. And that meant that for most developers, they interacted with that values file once or twice, in a 6-month period as they adjusted something or turned on a feature. We went through 3 major versions, and I think 200, I don't know, so 200 plus, 300 plus, minor versions of that Helm chart as we iterated. And we started small. We started with give me a deployment, a service, and a Cloud SQL instance, and then we iterated from there and kind of really, really improved it. But by the end of it, all of our services were using that Helm chart. We used, something like Renovate to submit updates for it, and developers didn't have to worry about most of the parts of their Kubernetes cluster working. They got, their metrics monitoring and their service monitoring for free. They could have their dashboards submitted to Grafana as part of that. They could, like, all of these different parts that improved. We would, for example, auto instrument with OTel. So when they turned on, when they got their Helm chart, we would ship the init container that would, automatically as part of the deployment, that would install OTel into their container and then add the correct arguments to run it. Or we would, there's all of these different things that meant that we could roll out tooling um, without developers having to either worry about it or to have to deal with, the complexity. They could just opt in or opt out. They could opt in and say, "Yep, I want this piece," or "Nope, I don't need this piece." And that was really powerful. We had teams shipping multiple times a day to their clusters or to their services. It was yeah. It was a lot of fun. It was really effective and efficient at what we were doing.
And does this Kubernetes API mental model apply to other tools?
We're seeing it more and more, and we're seeing, when Terraform first released, for example, Terraform was very much a just run it from your CLI, just run it from your local machine, don't worry about it. And then, we've seen more and more tools get built out to help, support this, whether that's things like TerraGrunt that allows you to abstract your Terraform modules. We've seen new kind of configuration languages, like PKL or Q, come out to say, how do I handle this? Seeing tools like Atlantis and Spacelift come out to handle the reconciliation, the GitOps model for Terraform. I think Kubernetes still stands above the others because of the ability for CRDs. Like, that is it can, other tools can replicate all the other parts, the idempotency, the fault tolerance, and the declarative nature. It can even handle the reconciliation loop. But CRDs exist, and as like a really big benefit to being able to, for you as a platform team, to be able to ship basically a Heroku type model for your engineers. And so when you're building out a new piece of tooling, consider, how do I do this in the easiest way for my developers? How do I make it extensible? How do I make it easy to interact with? How do I make it so that developers don't have to make as few choices as possible? Alternatively, they can make their choices as late in the pipeline as possible, be able to edit those and figure out, what's needed later on.
Up until now, we've been discussing tooling. What about the engineers that are working in these teams? In your experience, do they want to self-serve? And how do you evangelize these practices, to other folks that are out there? I don't imagine it's as easy as just walking up and saying, "Hey, everyone, from now on, you're all on your own." How do you go about doing that? Because a lot of times, we talk about the technical challenges, then the organizational challenges can sometimes be even bigger.
Yeah, yeah, no, you can't solve organizational problems with technology, and that just remains true no matter what you do. And you're right, you can't just rock up and be like, "Hey, you're on your own, good luck." It's about building and demonstrating that developer experience. It's about showing them that this way is easier. I think one of the I've seen this go right and I've seen this go wrong. And I've seen it go wrong when you mandate the use of particular tools. When you say to engineers, you have to come use our tools, and you get top down kind of buy-in. If you have to go compete for their usage of your tools, if you don't have a mandate that you have to use this particular set of tools, then all of a sudden this is easier, because then you actually have a product that you're building towards engineers and you'll actually solve their problems. You're incentivized to listen to them, fix how they're improve their pain points. I think, especially when you're first starting out, the goal is you need to go out and talk to them and see what is taking a long time. Are you, as the infrastructure team, for example, being a choke point in them getting their stuff out because you can't provision your RDS or your S3 buckets fast enough, or are you going through too many rounds of security reviews? Like, the thing, and you asked, do they want self service? And like, the answer is yes. I have only met a single engineer in my entire life who, when offered, was like, I don't even want to care about how much memory my app uses, just to deal with it for me. Everyone else, they want to be able to control how their app runs, where their app runs, and what it interacts with. What they don't want is to have to become Kubernetes experts to do that. And so that is where you can't just be like, hey, here's Kubernetes, have fun. You have to think about it from their perspective and figure out a way. Again, like the point here, where I guess we talked about shifting down, is to abstract what is going on and what is required, and start small. Start with one team. Think about how to build it for the others, but start with one team and slowly work your way through, solve their problems, because the best way to evangelize this is to not have to do it on your own, but to get them to go out and sell it for you, for them to tell their other developers at that company, oh, hey, we're doing it this way. It makes this really easy. You should go talk to the platform team to get onboarded as well. And then, you get onboarded. The having to compete is really like the answer there.
And if you could only give one piece of advice to a team that's getting started with self-service, what would it be?
That same one that I just said, like, don't go start small, start with something you can deliver, and iterate through solving specific problems at a specific when you actually run into them. Don't try to do everything all at once. It's going to be overwhelming to try to shift an entire team's stuff infrastructure into your pipeline. So don't spend the time to say, hey, we want to standardize and abstract to this one piece. We want to abstract the next piece, and then we want to abstract the next piece, and then we want to, slowly work our way up. But don't start with trying to do all of it, because odds are you're going to get it wrong, and you're going to burn up your basically political capital and your desire for developers to move onto your platform if you try to do all of it all at once. Your first impression is the most important there, and so starting small and kind of working through that.
Now, what's next for you?
I have a bunch of stuff going on, but I just moved to Sweden, for example, and so next for me is to, like, my wife has a baby on the way, and so next for me is to discover the challenges of being a dad, and figuring out the rest of life, perhaps how to scale child rearing horizontally or something. I don't know. Um, uh, how do I abstract raising a child? No, yeah, I don't know. We'll see. We'll see what happens.
I think actually, if you listen to a lot of the stuff that you mentioned throughout the course of this conversation, there's probably a lot of things that can be applied to many aspects of life. As someone who's not a parent, but has many friends who are, what you said about not trying to do everything all at once, scaling these things out, being realistic with the things that you have, not responding to a people problem with technology, despite the many wonderful things that we have nowadays. Yeah, there's a lot of other stuff that's not necessarily technological that will come in handy. So yeah, that sounds like plenty.
Yep.
And if people want to get in touch with you, what's the best way to do that?
Yeah, sure. You can find me on LinkedIn. You can find me on Medium. I'm sure there'll be a link to the post in question that spawned this. You'll find me on Medium. Um, you can reach out to me via email at contact@hans-connect.com. And I'm happy to chat, and yeah, yeah.
Okay, that's good. I guess also too, since knowing about your background and how long you've been working with Kubernetes, considering that Kubernetes is turning 10 years old this year, what do you expect to happen in the next 10 years?
Oh, that's a great question. Now you're asking me to predict the future,
And this
and
is off script. This is off script.
this is terribly off script. No, this is great. So in the next 10 years, I think that we're going to see a lot more development of tools that build on top of things like cluster API. So I saw a really interesting article the other day about how do we provision hundreds of Kubernetes clusters kind of scalably, and they talked about the challenges of using cluster API to build these out. How do we build, especially as we step into like a generative AI, as we've seen kind of over the last year? How do we step into a world where you can empower developers to really self-service. They don't have to come to infrastructure or platform and ask questions. They can talk to, this own little generative AI, this own little chat GPT for your platform specifically that will help answer questions about how to run it. I think we'll see a lot of build out of, eBPF, again, of tools like KApp, and there's a bunch out there that are trying to abstract, right, reconcile the principle of a service or a microservice or an application with all of the various parts of Kubernetes, and how do you do that properly? And so I think we'll see a ton of movement there. And yeah, we'll see. We'll see what else will come along. I don't know. We've seen a lot of change even in the last 4 years of how to run Kubernetes, and even in the tech world, right? I think anyone would be hard pressed 3 years ago at kind of peak of the pandemic to have predicted ChatGPT and the generative AI stuff that we've seen come out already, Copilot, things like that, and how much they've helped. So I won't sit here and try to predict 10 years in the future too far. So
Fair enough. Good. Well, that being said, thank you very much for sharing your time with us today. Really, really like the insights and how you're looking at this. You've spoken to a lot of people, but I do find your way of looking at this to be quite unique. So looking forward to seeing, future work as it comes out, and best of luck to you in the next steps.
thank you very much. Have a great rest of your day.
All right. Take care.